Astrophiles. This is Pat Cosgrove, and I'd like to welcome you to Cosgrove's Cosmos. Today we'll be discussing my most recent imaging project, IC1848, better known as the Sol Nebula. Today we'll be talking about the capture details for this project, including the fact that halfway through the project I shifted from an IOptron CEM26 Mount over to the brand new ZWO AM5 Mount. We'll also be talking about a brief overview of the image processing strategy for this particular project. Let's get started. This video is a companion to the overall posting for this imaging project that you'll find on Cosgrove's Cosmos. There you'll find more details about this particular target, why I chose it, the details about how I captured it, and a very detailed step-by-step illustrated walkthrough of the image processing done in this image. First, let's start by talking about the target itself. I've always been intrigued by the Heart and Soul Nebula found in the constellation of Cassiopeia. Not only are they close together, they're actually connected by a common bridge of material. Both of these nebulae are very large in size, and because of that, I avoided shooting them for the first 2 years that I was involved in astrophotography, because the telescopes that I had at the time had such a large image scale that I couldn't fit them into the field of view. This all changed when I put together my third imaging platform that was based on the Askar FRA400 scope. This 400mm Quintuplet Astrograph was the perfect instrument for going after larger objects like the Sol and the Heart Nebula. I was first able to capture the Heart Nebula in December of 2021. This was an 11.5-hour integration using the new Askar FRA400 scope, and I was very pleased with the result that I got. But during this period of time, I did not have the opportunity to go after the Sol Nebula with the 400mm wide-frame scope. I did try capturing a small portion of the nebula using my Astrophysics 130mm platform using the outstanding ZWO ASI1600MM-Pro camera. This effort was aborted early when clouds came in after only 2 hours of data capture. Despite the ridiculously low integration time, I decided to try processing the image anyways, and I was a little shocked by how good it did come out, even though I was only able to capture a small portion of the head of the nebula. I attribute this to the great performance of the 2600 camera. So this year, I really wanted to try to capture the Sol Nebula using the FRA400 wide-frame scope. Now, I don't have a 2600 camera on it. I have the classic ASI1600MM-Pro camera on it. But even though it's not quite as efficient, my plan was to have a very long integration for this particular image. Data capture started on the nights of October 21st and 22nd. And if you've seen my previous videos, you know that those evenings I was sick with a really bad cold, and illness shut me down from capturing more data at that time. I had so little data captured for the Sol Nebula at that point, it really wasn't worth processing it. So I waited, hoping that some opportunity would open up and I would be able to capture some more integration time. And that happened on November 23rd, where we had a clear evening and I was able to take the scope out, set it up, and capture another 3 hours of data, which gave me nominally enough to make it worth processing this particular image. This image is the result of 7.8 hours of narrowband data collected as 5-minute subs. This fell quite a bit short of the 15 hours I was hoping to collect, but circumstances as they were, this is the best that could be done, and this is the data we have to work with. It's also likely to be the last image I'll be producing this year. Typically in my area, clouds roll in towards the end of November, and they tend to hang around till March, and I'm pretty much shut down. Occasionally we'll have a clear evening, but often not extended enough to get enough data to make a viable project. So this may be the last image I'm able to produce this year. This imaging project is a little bit unique in that the mount that I started using was not the mount I concluded the project with. I started the project with an IOptron CEM26 Mount, which I've been using on the FRA400 platform since I first put it together over a year ago. It's given me some good results, and it's been a solid little mount, but I decided to make a change to go over to the new ZWO AM5 Harmonic mount. And this particular project took long enough that partway through I made that transition. I'm planning on doing an entire video on the transition over to the ZWO AM5 mount, so I don't want to go into a lot of detail here, but I think it's probably worthwhile to share with you why I chose the CM26 to begin with and why I'm making the change to the AM5 now. First, let me say a few things about the IOptron CEM26. When I first chose it when I was building this platform over a year ago, I was looking for something that was lightweight and would be a great mount for portable applications. I started with a 1.5-inch stainless steel tripod, which came in at about 12 pounds. The CM26, which was new at the time, the head itself weighed about 10 pounds, but it bragged a load capacity of 26 pounds. So it's a pretty nice small package for those people who are looking for something that can be portable. The optical tube assembly comes in at about 12.5 pounds, which is about half the capacity of the mount. And so this was a good combination, and it served me quite well for the past year. I've gotten a lot of really good images with this combination. So why make a change? Well, I've been running into a few issues. One of the issues has to do with the backlash in the system. When I first got it, I measured a backlash on the declination axis of almost 5 full seconds. That's a lot of backlash to deal with. I contacted IOptron, and they provided excellent support and gave me a process where I could go in and adjust the belt tension on the declination drive, which would reduce that dramatically. By following those directions, I was able to reduce the backlash on the declination axis to about a second, which was perfectly manageable using PhD2 and the right kind of tuning to get the guiding that I wanted. The downside of this is you have to get the tension, you have to loosen a nut and you have to move a mount. And that mount is plastic. And I was always uncomfortable cranking down to tighten that too much, lest I damage the plastic. Because of this, over time, it would tend to slip, and slowly my backlash would crawl from 1 second back up to around 4 or 5 seconds. So I was always going back in to change the backlash and adjust the belt tension. And I found that I had a state where the drive was shifting over time, and it wasn't as predictable as I'd like it to be. The second issue was it really wasn't as light as it could have been. It's true that it supported 26 pounds and the head only weighed 10 pounds, but for that to really work, you have to put in a counterweight and a counterweight axis, which adds another 10 pounds. So now you have 20 pounds of mount carrying a 26-pound load. It's still not unreasonable, but it's not as advantageous as I would like it to be. Finally, the last problem is I've been starting to get more and more cases of elongated stars happening. And when I look at the mount and I have the clutch locked, I'm seeing a wobble develop in the head that wasn't there when I first started. I'll share a video of that with you here. Now, I'm assuming that something has loosened up inside the mount, and I probably can disassemble it and fix that. But for right now, it's been a little bit frustrating. While this was all going on, I began to hear interesting things around the new ZWO AM5 Harmonic mount. Harmonic mount technology is not something I've had personal experience with, but I was very intrigued to see what it could do for me. It kind of sounded like the future, and the ZWO offering looked very attractive. The machining looked like it was really well done, and the feature set that it was providing for the price point was pretty good. It was more expensive than the CM26 mount, but it was something I wanted to try out. The mount itself weighed about 11 pounds and had no need of counterweights whatsoever, and without counterweights, it could handle a load of 26 pounds. Right there was a huge weight advantage that I found very attractive. If you put a counterweight on, you can take the load all the way up to 44 pounds. That makes this small little mount pretty flexible in how you may use it. It seemed to me that these characteristics made this mount really attractive, and it had a wide variety of things you could use it for. The other aspect, which is kind of interesting, is the fact that you didn't really have to do very careful balancing of the mount. In fact, there's no good way to really do balancing of the mount. But that makes it actually pretty convenient for someone who's setting things up in a driveway. I could very easily lift the mount, drop it off in the driveway, do the polar alignment, and start working. And I didn't have to worry about precise balancing and tweaking as things were changed. That made this a pretty robust design for my application. Finally, the whole configuration sat on a carbon fiber tripod that weighed almost 7 pounds less than the stainless steel tripod that I was using for the IOptron configuration. Having said that, I recognized going into it there was a certain element of risk by going down this path. While the mount looked like it was really nicely done, it is a first-generation design, and it's not unusual to have things discovered about first-generation designs down the road that would cause some need for change and update. And so I was taking the risk of being an early mover on this, and I decided I was willing to do that. The second issue is it was pretty obvious that ZWO has optimized this configuration to work with the ASI Air series of controllers. It was very well integrated, and that looked like it would be a very smooth operation. However, I use a camera rotator, which ZWO does not even make, doesn't have a product offering for. And the ASI Air family really wants to work with ZWO products only. So it was pretty evident that I was going to have to control this using a laptop and the standard ASCOM platform. And there was some early problems with the ASCOM driver when the mount was first released. Most of those have been resolved now, but given the fact we're still early in its product life, there could be some other driver issues that I might run into. Finally, I wasn't entirely satisfied with how the cable mounting was done, as a portion of the mount that's moving has cable sticking out of it, and it seemed like cable management would have to be done carefully to avoid potential snags. Crossing the platform over to the new mount from a physical perspective was pretty easy. Basically, the entire tube assembly I just clamped onto the new mount. The biggest issue was the cable management that I had done before needed to be changed fairly substantially to optimize it for this configuration. My CEM26 had a built-in iPolar polar alignment camera, so I needed to have something like that since I'm setting this up in the driveway each night and I have to do polar alignment. So I ended up getting a PoleMaster and a mounting bracket, which you can see here, that would allow me to easily do polar alignment from the driveway. So I had to add that in, but that was pretty straightforward. A bigger issue was really setting things up from a software perspective. I had to bring in new ASCOM drivers. I had to create a new profile in PhD2, and then I was going to have to make sure that I had appropriate parameters for PhD2 in order to get the tracking performance that I wanted to get. Finally, I'd have to create a new equipment profile for Sequence Generator Pro, which is what I use for managing the capture of my sequences. So on November 23rd, I took the new mount out, went out a little bit earlier to set things up, went through all the new calibrations you had to do for PhD2. I did calibrations, I read guide assistance so that I could tweak the numbers in, and finally I started my new capture sequence using the new equipment. And I sat by and waited to see how good the performance was going to be. After 15 minutes or so, I was seeing reported RMS errors of 0.38 from PhD2. And I was very nervous about that because I had never measured a guiding error that low. So I had to assume that something wasn't working right. I left things running and I went back inside the house to see if I could take a look at the subs. I should mention that the way I have things set up, I have one laptop driving each platform that's doing captures, and it writes the subs directly to a cloud drive on Dropbox. And that's propagated to all my other computers so I can, at any point, look at the subs as they're coming in. And so I pulled up the subs and looked at them, and they look great. The stars had nice pinpoint round images, and everything else looked great. I saw no problems, so I let things run. For the entire evening, I think the guide error did end up going up a little bit more. I think I went up to 0.41. but I was delighted with the performance that I was getting. I should also mention this is about 4 times better than the guiding performance I had been getting on the CM26. CM26, I usually have errors that were over 1.0, and some evenings I've had it as high as 1.88. Now, this hasn't been a problem with a 400 millimeter scope. It seems like even with those errors, I was able to get good, solid images. But it's just delightful to be able to swap over to something that's even lighter and be experiencing the kind of performance that I was seeing. To give you a better feel what this looked like, I pulled the guide logs from one of the sessions with the CM26 and another from the session with the AM5, and let's take a look at them. First, we have the CM26, and you can see the error there is a little bit around the 1.0 region. But you can also see some of the cyclic errors that I was running into. Now when we shift over to the AM5, I have the vertical scale about the same, so they're fairly comparable, and you can instantly see that the errors that we're encountering here are about 4 times better than what we saw with the CM26. So I was pretty happy with the results I was getting from this new mount. So this is the first time I took subs that were captured from 2 different mounts with 2 different air profiles. And so I wasn't sure what that was going to end up looking like when I put things together. I assumed it would come together with no big issues. But I was very pleased with the transition that I've made. The new mount is much lighter. There's no balancing I have to do, and the tracking has been superb, at least so far. So I've been pretty happy with the shift moving over. With that, let's take a change here in topic, and let's start talking about the image processing. As I mentioned, I have 2 nights of data on the CM26 mount, and as I did the blink analysis, I found cases of elongated stars. Now, normally the way I deal with this is I eliminate those subs that have elongated stars, at least the worst ones, so I don't have bad data going into the pre-processing steps. But in this case, since I was really starving for integration time, I really didn't want to throw any frames out if I could avoid it. So I decided to keep them in, and I figured there was a couple things that I could rely on to try to mitigate this problem. The first is the fact that I know I have some good data with some really nice tight round stars. Therefore, if I set things up in the pre-processing, the image integration rejection criteria could be set such that hopefully I would throw out some of the outliers and it would clean things up a bit. And I've seen this happen in the past, so I was hopeful that that would give me some benefit. The second thing I thought was going to be very helpful is the fact that I'm doing a starless image processing workflow. Well, if I'm going to remove all the stars, then I guess I'm not going to be too concerned about the fact they might be slightly elongated. The trick here, of course, is at some point I have to add the stars back in. And so the stars I had back in had better be nice and round. I figured worst case, I knew I was getting really good stars from the AM5 mount, and I could do an image integration of just those frames. Yes, there would be fewer subs, but stars in general are never starved for exposure, so I wasn't too worried about that. I could create a stars-only image from just the subs from the AM5, fold those back into the image, and everything would look great. Maybe I wouldn't need to have to do that. I would have to see where things were when I got to that point. But the bottom line was I felt that there was a way to get there. And maybe it's a little sneaky, but I figured it should work. You may be surprised to hear me talking about elongated stars. And the reason I bring this up is it seems like when someone becomes an accomplished astrophotographer, what tends to happen is they share their positive results and they put positive spin on those results. And you almost get the impression that once you've attained a certain level of skill and competence, you don't run into problems like that anymore. Those are problems that just beginners have. And in fact, I don't think this is true. I don't care how advanced an astrophotographer you are, you're going to have nights where your gear is just not behaving the way you want, or the software is doing something that you didn't anticipate. And you're going to end up with some data that has some issues, and you're going to have to be able to work around that or to mitigate those problems. This happens in a very common way. I don't know of any astrophotographers that don't have some horror stories about problems in their data that they had to deal with when they were processing. One of the skills of learning astrophotography is to recognize these kinds of issues, work around them, and then work to improve your system so that you don't run into them again. Now, an experienced astrophotographer maybe runs into it less often than others, but everybody has these problems. They just don't talk about them. Maybe that's one place where I'm different. I don't consider myself an advanced astrophotographer. I've only been doing this 3 years, and I'm still learning, and I realize I have a lot to learn. But I've been trying to share, my learning process, and I don't see how you do that without sharing the warts and the mistakes that you've made along the way. Now, in this case, it wasn't really a mistake I made other than a problem with my mount. I think that it's very common to have issues like this. And so if you're running into a problem with a recent project you're working on and you have problems in your data, don't feel like you did something wrong or that you have these problems and others don't. They're very commonly occurring. People just don't talk about them. And I tend to do that because I see them all as a learning opportunity. So let's talk about the workflow that I use for this particular image. And it should be no surprise that it's basically identical to the workflow that I used with my previous project. Again, this is a narrowband SHO 5-minute sub image, so why would I do it different? And the last one, I had modified my standard go-to workflow to use the SHO normalization tool that Bill Blanchard has recently shared. So I've had some changes there. Let me show you what this workflow looks like. Part of it involves creating a synthetic luminance image, which is then processed to go after sharpness and detail. And part of it has to do with creating a color SHO image, which is processed primarily looking at managing noise and producing a pleasing color position. More recently, I've been creating this color image by taking the master images in the linear domain and using the channel combination tool to create my first SHO color image. While I'm still in the linear domain, I go starless, and for this case, I've been using Star Exterminator to do that. And now that I have a starless image in the linear domain, I'm using the SHO normalization tool by Bill to get my initial color position. At this point, I then go take it nonlinear, and the remainder of my color processing is done in the nonlinear domain. Once I get the color where I want it, I then take the luminance image, fold that in using the LRGB combination tool, and then finally the stars are added back in using a screening equation and pixel math. In this case, I happen to use the SHO stars only image as the basis for the stars that were added back in. I was a little surprised by the time I got to this point of my processing when I was looking at the SHO stars only. I saw very little evidence of the elongated stars. That had been greatly mitigated by other steps leading up to this point, and I found I didn't have to do anything too special to get an image that looked pretty reasonable. The other aspect is that by using the color images, I had a little bit of color being shown in the stars without anything funky or too strong happening. And I kind of like the idea of having at least a little bit of color in there. So I ended up using that particular image. As I completed my image processing, I realized that once again, I was ending up with an image that had a lot of strong color saturation and contrast. After all, I am a high color guy, and that tends to result in the decisions I make and how they add up to generate the final image that I ended up with. Now, recently, I've been taking the high color image and creating a second version that is sort of a mid-color version where I tone things back a bit. And I've been asking for feedback, and I've asked for feedback from friends, and I've asked for feedback on by posting it on Twitter and getting people voting on it. And I've done this several times now, and I see something very consistent happening, and that is the vast majority of the people don't like the high color look as much as I do. And so rather than continuing to ask the question and getting the same answer, what I do now is I sort of get the image to where I like it, which is very high in color. And then I sort of tone it back a bit, and that's the one I lead with. So that's what I did here. Here is the image that I thought looked best to me. And like I say, it's a pretty strong color. Then I backed off a little bit, not too far, just a little bit, to this mid-color image here. And this, in fact, is the image I'm going to put face forward as I do this project. Many people seem to like this slightly lower color position, so this will be the image that I use as the main image on my image posting and what I'll be sharing more broadly. And so with this, I now have an image of the Solar Nebula that I can add into my portfolio. I'm really glad to have it. I think it's a really interesting target, and I'm glad I have something which captures the entirety of it in one frame. I'm a little bit sorry that I wasn't able to get higher integration, because I think it really would have smoothed things out. And there's some areas in nebulosity which look a little lumpy, some of the background that can look a little lumpy because of the limited integration there. So I guess that gives me an opportunity for a future year to add more time into this and more room to growth to take this image where I'd ultimately like to see it go. As I said, this is likely to be my last imaging project of the year as we enter the winter and spring months that are clouded over. I'm planning on creating quite a few more posts on my website and more videos for this channel, including an overview of my experiences with the AM5. I'll be talking about what's been going on with the website and new things coming up there. I'd like to talk about a bunch of how-to technical articles, which I just haven't had a chance to get to. And then finally, several people have asked me, how do you go about submitting images for publication? I started doing that a little bit over a year ago. And as of this year, I've been very lucky. I've gotten 9 images published. And so I'll be writing something that shares the simple things I do to try to get my images in front of editors who may or may not choose them for publication. So stay tuned for more content, and make sure you subscribe to the channel and ring the bell so you don't miss anything new as it comes along. And as always, your questions and comments, both on this channel and my website, are very much welcomed and appreciated. Signing off, this is Pat Cosgrove for Cosgrove's Cosmos, and I wish you clear nights and excellent seeing.